All right, here we are in problem number 3. All right, there's a claim made here. I'm hoping these ideas do look familiar. Sodium atom could easily lose an electron to become more stable. So part of this is based on the atomic structure of sodium. So 11 protons, 1, 2, 3 shells, 2 electrons in the first shell, and 8 electrons in the second shell, leaving 1 single electron in the third shell. So this is the one that the claim is talking about. Easily lose an electron, that one. To become more stable, it'll have an octet. Okay, but now let's look at the energetics. 498 kilojoules per mole is the ionization energy. That means that this number here will be 498 kilojoules per mole. It'll be uphill, though, endothermic, to form the sodium ion and a separated electron. So let's evaluate these. Can sodium easily lose an electron? To answer that, I'll look at the chart of ionization energies, table 93C. It's actually 92C. But looking at this graph here, you can see that sodium is here. And it's one of the very lowest ionization energies that exist on the periodic table. So, of all these elements, sodium has the least strong hold on its electrons. Therefore, it can easily lose an electron. Okay, so of all the elements, yes, sodium atom is one of the easiest to lose an electron. But to become more stable, we have a problem, because here, this is a high potential energy state, and therefore is less stable than the neutral atom. So we have a problem. What you were taught in 8th grade is only a partial truth. We have a problem. The solution to the puzzle we had above is going to lie in the concepts of bonding, chemical bonding. So here we saw that just making the ion itself is not making it more stable. So go ahead and do this with me, if you haven't already. Make a new graph of potential energy. Start kind of in the middle here this time. And let that be the Na neutral. And then consider going uphill to make the ion. Alright, if we look now at these pictures here, you can see that, as it says in words, a sodium ion is always engaged in some kind of bonding. We know that bonds, whether they're ionic or friendship bonds like this, lower the potential energy. So that would mean this is a false representation here. We're not going to have an unbonded sodium ion. If sodium neutral reacts to lose an electron, it will turn into an ion that bonds with something. Bonds with something. And that would mean that we can take that into account and say the bonds that the sodium ion forms can lower the potential energy. And so maybe we end up with something like NaCl, ionically bonded, which is lower potential energy than the neutral sodium and neutral chlorine, for example. And this is why sodium ion is very common, because it can always form some kind of bonds that lower its potential energy, whereas this sodium neutral is not so common. Not at all natural, not common, not found in nature. it's only man-made. And it has to be kept away from anything that it could potentially lose electrons to form these bonds. So I'm hoping this makes sense to you. Without bonding, this would be unstable. With bonding, it can be a nice low potential energy, a natural process to go downhill.